This is unit 8.4, I'm sorry, 7.4, special right triangles. In this video, we're going to explore two types of special right triangles. The first one is 45, 45, 90 degrees. I want to note here, we call them special right triangles because certain patterns that they carry make our calculation a lot easier. But at the end of the day, if you don't remember these patterns, you're still relying on Pythagorean theorem to help you make the calculations. So don't sweat it. It's just a matter of practice and familiarity. So coming back to this 45, 45, 90 degrees. In a right triangle, if one of the angles is 45 degrees, the other one must be 45 degrees. Notice that now I have a equilateral triangle. I have an isosceles right triangle. In other words, these two legs are exactly of the same length. Therefore, if one leg is x, the other leg must be x. If two legs are both x, so if I do my Pythagorean theorem, a squared plus b squared is x squared plus what? Plus x squared should equal c squared. Now, 2x squared would equal c squared. If I take a square root on both sides, I would have 2x squared, make sure it's inside, would equal square root of c squared. On the left-hand side, the c comes out. On the other side, the x comes out. There's nothing we can do about root 2. It's not a perfect square. So my hypotenuse is x root 2. Okay, now so far we're good. Just notice that as long as we know the leg, we will know the hypotenuse. We just multiply by root 2. We don't need to go through this calculation again. Okay, that's how it makes life easier. So let's look at this. If I have 45 degrees, I have an isosceles right triangle. My two legs must be the same. So my x is 8. If my x, in this case it's my leg, is 8, my hypotenuse is just 8 times 2. Now look at this side. Look at this one. Same thing, right? 45 degrees, 45 degrees, isosceles right triangle. Therefore, my leg, in this case, y is the other leg is labeled as y. Therefore, it must be 25. If leg is 25, the other one, the hypotenuse is 25 root 2. Over here, isosceles right triangle. This side and this side equal. However, I don't know them. I only know hypotenuse. If hypotenuse is 19, remember hypotenuse is whatever my leg is. In this case, it's x times root 2. I've got an equation there. So all I need to do is 19 divided by root 2 would equal x. If I want to simplify this, I multiply root 2 over root 2. So my x is 19 root 2 in the numerator. In the denominator is just 2. Okay, so it's 19 root 2 over 2. And that works for y as well because they equal each other. It's an isosceles right triangle. Now let's look at this kind of triangle. This is called 30, 60, 90. In 30, 60, 90, we focus very strongly on the shorter leg. So we say if the shorter leg is x, then we can determine what is the situation with the other two sides. So let me draw a right triangle. And then let me do the other side. Okay, there we go. So it looks pretty good, right? Notice that this part is 30 degrees, this is 90 degrees, and this is 60 degrees. So what I did here, and we said the short leg is x. What I did here is that I create a reflection. I literally just flipped The triangle on the right hand side, I flipped it over on the left hand side. Therefore, you know the two right triangles are congruent. So this one would be 30, this one would be 60 because they're the same right triangle. And this one, of course, is 90 degrees, right? Notice also if I flip them, if this part is x, this part must be x as well. So I've got 2x here. And also notice that they are all 60 degrees. If the angles are all 60 degrees, remember, angle and the side, the opposite of the angle, is always a pair. The angle and the side opposite of the angle is a pair. So if three angles are exactly the same, the three sides must also be exactly the same. So all the sides are 2x. Now let's come back to my original right triangle, this special right triangle, 30, 60, 90 degrees. Did you notice that we now know the leg, the short leg is x, the long leg now is 2x. If short leg is x, so if I plug in my a squared plus b squared equals c squared, if my short leg is x, then it becomes x squared plus b squared, which is my longer leg, would equal my third side, which is my 2x squared, right? So it's x squared plus bx equals 4x squared. I minus x squared on both sides. I now have b squared equals 3x squared. Now if I take my square root, b comes out, x comes out, root 3 stays. So in other words, this side is root 3. X root 3. Okay, now I'm gonna erase the rest of the reference just to make my board a little cleaner. Okay, and also see if I can erase this right triangle here. So there we go. Now notice this is a little more confusing for some, but remember, your strong focus is here, is the short leg is x. If you know your short leg, immediately go to the hypotenuse. Your hypotenuse is 2x. And then you can use your Pythagorean theorem to figure out the longer leg if you don't remember it, okay? Another thing is, now I'm going to change my color. How do I know? It doesn't look, this square root of 3 really makes it confusing for us. How do I know that this 2x is actually the longest side? It's longer than this. It's bigger than this. If I rewrite 2x into square root 4x, right? Really, this, if I rewrite this, I can rewrite this into square root 1x. Now you see I have a 1, 3, 4 relationship right here. And that demonstrates to you, yes, indeed, this makes sense. This is the longest side. So going back to our original slide, change my color back to red. We said if my short leg is x, my longer leg, my hypotenuse is 2x, and then this side is root 3x, or x root 3. Okay, so let's do some practice. Let's see here. If my short leg is 5, my hypotenuse must be 2 times 5, that's 10. And then my longer leg is my short leg times root 3. Over here, my short leg is 14, therefore my hypotenuse must be 2 times 14 is 28. And if my hypotenuse is 28, my longer legs must be root 3 times the shorter leg. So it's 14 times the root 3. Over here, I don't have the short leg, but I have the hypotenuse. Hypotenuse is 2 times the short leg, equals 32. Therefore, my x is 16. And now that I know my short leg, my y is just 16 times root 3. over here, number 7 is exactly the same as 6, so I'll leave that alone with you. The number 8 is different. If I have short leg being y, I don't know what my short leg is, but I know my long leg. My long leg is root 3 times my short leg, which is y, equals 20. Y would equal 20 divided by root 3. And if you multiply root 3 over root 3, you would have 20 root 3 over 3. So here is 20 root 3 over 3. If my short leg is 20 root 3 over 3, I can do my hypotenuse is 2 times that, so that is 40 root 3 over 3. Okay? Number 9 is the same, so I'll leave that for your own practice. Here are some mixed practices, so let's do a few together. I have a 45, 45, 90 special right triangle. Therefore, remember my hypotenuse should be root 2 times my leg, x. And since I know my hypotenuse is 28, I just use 28 divided by root 2 on the other side. And if you simplify it, you should have 28 root 2 over 2, and you cancel that, you should have 14 root 2. And because it's an isosceles right triangle, x and y are the same. Over here is 30, 60, 90. 30, 60, 90, I need to focus on the short leg. I don't have short leg, I only have hypotenuse. But I know hypotenuse is 2 times my short leg. Therefore, my y is 8. If my y is 8, my longer leg is my short leg times root 3. Whoops. Let's do one that looks a little bit more intimidating. So let's do number 14. 30, 60, 90. I don't know my short leg. I only know my longer leg. I know my longer leg is 15 root 3. My longer leg is also root 3 times my short leg. So if I just divide both sides by root 3, my short leg is 15. My short leg is 15, my hypotenuse is twice as much, is 30. Number 17. Let's do number 15. 45, 45. I don't know my leg, right? So, but I know my hypotenuse is 9 root 2. My hypotenuse is also whatever my short leg is, my leg is times root 2. And this cancels, root 2 cancels, x and y both are 9. Number 17. Number 17, it's a 45, 45, therefore it's an isosceles right triangle. Same thing. My hypotenuse is root 10, and my hypotenuse should be whatever my leg is multiplied by root 2. If I divide both sides by root 2, I would cancel this root 2, and over here I would have 10, combine the square roots because it's a division, I would have square root of 5. X and y both equal square root of 5. Okay? I think the rest of them are pretty straightforward. Let's do 16. 16 is 30, 60, 90. So the focus is on the short leg. I don't have the short leg, I have the long leg. Long leg is 6. Long leg equals root 3 times the short leg y. Therefore, right? And then if I do my simplification of the radical, I would have 6 root 3 over 3. 6 root 3 over 3 equals y. And therefore y, if I simplify that, it's 2 root 3. Cancel the 3 here. Now if y is 2 root 3, hypotenuse is twice as long, so it's 2 times that. It's 4 root 3. Okay? let's look at some of these. These are a little bit more complicated, but they're still the same thing. Let's see. I've got a isosceles right triangle here, 45, 45, 90 degrees. So x and y must equal each other. But it doesn't help me because I don't know x and y, and I don't know the length of this one, of the hypotenuse, right? However, in the right triangle up here, I have another special one, 30, 60, 90. In this case, I know my short leg. That's really wonderful, because if I know that, I know z is, the hypotenuse is 2 times 9 is 18. So if I know this is 18, I can calculate this one, the longer leg in the 30, 60, 90. That's root 3 times the short leg. So that would be 9 root 3. If now I come down to this right triangle, if I have 9 root 3 there, and we know that the in this special right triangle, the leg equals root 2 times, the hypotenuse equals root 2 times the leg. And therefore, if I just divide root 2, I would have that. Now I need to simplify this by multiplying root 2 over root 2. So I would have 2, root 2 times root 3 gives me root 6, and then 9 stays. So that is my x and y. Both of them equal 9 root 6 over 2. Okay. 20 is exactly the same. Just they give you information of the leg, you need to solve for x first. And then the rest of it, you can take care of it yourselves. Number 21 is fairly similar. You've got the hypotenuse in this 30, 60, 90 special right triangle. Therefore, you know your x is 6. If your x is 6, you know the longer leg of that right triangle is 6 times root 3. You have 6 times root 3, then that leg in this right triangle, this is 45, 45, and so so this leg and this leg are congruent. So that's 6 root 3. That should be the same. And if you have that, you know the hypotenuse is just that times root 2. So it will give you 6 root 6. Okay. Number 23 is very much the same. You solve for z first in this right triangle, and then go for the other special right triangle. Number 22. Number 22, it looks intimidating, but notice in here, I like 30, 60, 90 slightly better, only because when the short leg is given, I immediately have the hypotenuse, which is 2 times the short leg, and that's 14 root 3, right? And then on this side, I just need to, whatever the short leg is, multiplied by root 3. So that's 7 root 6. Now, this 7 root 6 is also the short leg in the bigger right triangle. Therefore, the hypotenuse, which is y, would be twice as much. So that would be 14 root 6, twice as long as the short leg, right? And again, over here, I would have the short leg, the long leg equals the short leg multiplied by root 3. So I would have 7 root 18. If I simplify that, that's 2 times 9 inside the roots. 9 is 3 squared, so 3 comes out. I have 21 root 2 for z. Okay? Not challenging, but it does take careful observation of which side is the short leg and which number belongs to where. So I'm going to stop there and see if you can finish the rest of it. If you have any questions, feel free to ask. Bye, guys.